We are setting it to ensure that it's well set. How is it? Let's come up. We are live. Good afternoon. Is it okay? Please, let us be sincere. If it's okay, let me know, please. Up the vertical is not vertical. Is it horizontal now? Please tell me, please, before we start. I want your comment. It is too close to the board. But is it horizontal? That's the question. Is it horizontal? Is it normal? It's too close to the board. You can see the board clearly. Okay, let me write on the board and see. So we are going to start with integration. We are going to start with integration. So let's look at it. Can you see it, please? We are starting with integration. Please let me know your mind, please. Can you see? Can you see that? Integration. Can you see it? Okay, how is it? Hope it's not vertical, it's horizontal. It's normal, right? Is it normal? Yes, it's normal. Beautiful. Fine. Are we together now? Oh, very good. Thank you. God bless you. God bless you. God bless you as you come up. God bless you. God bless you. Okay, so we can start. Should we start now? Shall we start? We should start. Beautiful. 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 Thank you very much. Thank you very much. As I welcome you to this special tutorial class organized for students preparing for examination in MTS 102 and 106. So we are going to start with the topics in MTS 102, and that is going to be integration. We're going to start with integration. Okay? Now, integration. What is integration? Integration is anti-differentiation. That is, the opposite of differentiation is integration. Let's take, for example, if the rate of change of a function y with respect to x is equal to g of x. Suppose the rate of change of function y with respect to x is equal to g of x. That is, the derivative of y with respect to x is equal to g of x. Now, if we cross multiply here, we're going to have the y is equal to g of x dx. So, now, introducing an integral sign. By the time we introduce an integral sign, we have integral of dy is equal to the integral of g of x dx. So the moment that integral sign is introduced, it's going to nullify this derivative sign, this d. The integral will nullify it, and we are going to have what? You have y is equal to the integral of g of x dx. So that is how we arrive at the value of y from, the rate of change of y with respect to x, which has given us the integration of the function. Now, as I've said, integration is anti-differentiation. Okay, so clearly we have been able to see now that when we are given the rate of change of a function y with respect to x to be g of x, to get the integral value of that function, we have to put integral sign on g of x. So there are so many examples that will be illustrated in the course of this lecture. So let's start with what we call standard forms. Standard forms. Now, integration is a little bit more technical than differentiation because it has a lot of rules that guide it. And that is why we have the concept known as standard forms. So in our standard form this afternoon, we start with the integration of trigonometric functions. The integration of trigonometric functions. Let's start with the functions that are trigonometric. Okay, we start with the integral of sine x dx. You know, anytime you integrate the integral of sine x dx, you are going to get minus cos x plus c. This c is an arbitrary constant that must be added each time you integrate functions that are not definite. This integral is not definite because it doesn't have limits both, down and up. There's no limits. The lower limit is not there. The upper limit is not there. You could recall very well that when we were dealing with differentiation, if we differentiate a constant, we get the zero. So, but in the case of integration, when you integrate a function that is not definite, you must add a constant c. Now, at the same time, if you integrate cos x dx in integration, you're going to have what? Sine x plus c. You can observe that these values are the opposite of what we obtain when we differentiate them. Okay? Now, if you integrate the function exponential x dx, don't be surprised. Anytime you integrate this kind of function, you are still going to get what? Exponential x plus c. Okay? That is that. Now, if you integrate, let's continue. Let's continue. Since we are dealing with integration, I think we can continue without any much ado. So now, let's look at this. Let's look at this. Let's look at this. Now, let's look at this example. Okay. Now, suppose we are to integrate a function x raised by n dx. N here must not be equal to what? Minus 1. It might be equal to minus anyway, but in most cases, our n, let's assume it's not equal to minus 1 because it depends on the situation. So our n is not equal to minus 1 generally. Okay. So now to integrate this function, okay, now we are going to add a variable 1 to this n. That is, we're going to have what? X raised by n plus 1. Then the result will be divided by what you have here, all over n plus 1. Then plus a constant c. That is how that is to be integrated. Okay? Now, we have another one. Don't forget, we are talking about standard forms. These are rules, standard rules that must be complied with when you are integrating the functions. Okay? Now, in this case, we have what? Dx all over x. We are integrating a function dx over x. So anytime you are integrating this kind of function, that you have your variable as the denominator and you have the differential constant as the numerator. So it's going to be what? It's going to give log base e of what you have here, x, which is the same thing as ln, x. It's the same thing as ln x. Okay? But don't forget, you must add your plus c. You must add your plus c. Okay? Now, let's look at another one. We are trying to look at this generally now, so that by the time we start with examples, it will be easier to understand. It will be easier to understand. Okay? Now, integrate dx all over a squared plus x squared. Now, this time around, we have our integral as the ratio of, that is 1 all over a squared plus x squared. That is what we are integrating. That is our integrand. Okay. Now, how do we integrate this? Anytime you have this kind of form, anytime you have this kind of forms where you have a, it's a real number here, and our x is the variable that's unknown. So we are asked to integrate this kind of function. What you just need to do is, first of all, look at this denominator. You have a is a constant, and x is a variable, and each of them is a square. So generally, the result will be what? 1 all over a arctan x all over a plus c. That is that. We are going to illustrate with examples. So don't worry. We are going to illustrate all this with examples. Now, suppose we have the integral of dx all over the square root of a squared minus s squared. How do we integrate this? Beautiful. Now, you could see that here we have a subtraction sign, that's minus sign, and we have a square root. It's different from this, where there's no square root, but there is a plus sign. So what you just need to do is, you're going to say arc sine, arc sine x all over a plus c. It's a rule that must be followed. That is how that is done. Okay? Don't forget, I said our a is a constant. Now, we could also have something like this. You could also have something like this. I hope we are following. Beautiful. Beautiful. We could also have something like this. Okay. Now we have exponential, the integral of exponential y dy is the same thing as exponential y plus c, just like integral of exponential x dx. Okay. Now you can also have something like this. You can also have something like this. Okay. Suppose you have du all over u squared plus 9. Beautiful. Now, if you look at this du all over u squared plus 9, you will observe that it has something very close with the earlier one that we say that the integral of dx all over a squared plus x squared. You see, they are very, very similar. They are very similar indeed. The only difference is just that instead of variable x to be used here, we use the variable u. Okay, so what you're going to do now, if you could collect that, we said that that result should be 1 over a half tan x all over a plus c. So now we try to evaluate this by saying that this will be in the integral of du all over what? U squared plus 3 squared. Okay, you can now see that this looks like this. It looks like this. It looks like this. So obviously here now, our constant a is going to be 3. So that will now be, using this principle, we have what? This will now be what? 1 all over what? 3. Because our a, from here now, if you compare this x is u here now, like I told you, du, dx. So our a will now be 1 over 3, half tan, x all over a, x all over 3 plus c. That is the result for that. That's the result for that. But mind you, it is u that we use here, so that's half tan u. Sorry about that. Instead of x, we are using u. So don't be confused. So that's about that. Suppose you are also given the integral of this z all over z is the same thing as the integral of dx all over x. So that will be what? Log z base e plus c. It's as simple as that. So these are the standard forms that you must be acquainted with if you are able to, if you are going to be able to solve integration problems adequately well. You must be familiar with all these standard forms. They are standard. They are standard. So let's look at examples. Let's quickly illustrate with examples so that all these things will not just be a mirage in the course of our lecture. Now, the very first example here, we are asked to integrate example 1. Example 1, integrate the following functions. The following functions with respect to x. That is, the first one is x raised to power 8. The second one is the cube root of x. The third one is 1 over x raised to power 6. The fourth one is 1 all over the cube root, square root of x raised to power 3. And the next one is 1 all over the square root of 9 minus x raised to power 2. The next one is 1 all over 25 plus x squared. Why the last one here is sine square half x. The sine square half x. Hi, I'm Dr. Hoje. So you are welcome to this live session of our tutorial class today. So now, example 1. Integrate the following functions with respect to this. So I hope we have written the examples down, or we have noted them. So we'll be solving them one by one. Let's start with the very first one. The very first one, solution x raised to power 8. That is, we are asked to integrate x raised to power 8 dx. That is the meaning of that statement. Integrate the following functions with respect to x. Okay. Now, like I said, when I was showing you x raised to power n dx, I told you you will add a constant 1 to n. So our n here is 8. So to what? X raised to power 8 plus 1 all over 8 plus 1. So plus c. Okay. So, and x raised to power 8 plus 1 is what? That will be what? X raised to power 9 all over 9 plus c. So the answer to that is x raised to power 9 all over 9 plus c. Okay? Now we move to the next one. The next question. Let's move to the next question. And that is the cube root of x. The cube root of x. Let's move to the next question. The cube root of x. How do we solve the cube root of x? Very simple. First of all, what you just need to do is try to rewrite it in a form that will be easy. Okay, the second one, now, like I said, the square root of, the cube root of x. So this one means you are integrating what? The cube root of. Now, as a student of mathematics, you try to, rewrite this in an index form so that it will be easy. Okay, now, when you have, remember in your principle of law of indices, this cube root is like 1 over 3. You can remember that. So you have what? Your x will now be what? X raised by 1 all over 3 dx. Okay, that is it. Now, using the constant x raised by n, or the x, the other time I told you, our n here is 1 over 3. So you add 1 to it. So you have x raised by 1 all over 3 plus 1 all over what? All over 1 over 3 plus 1. Okay, plus c. So if we had 1 over 3 plus 1, let's quickly do that. That should be easy for you. It's 1 over 3. You know that, and that is 4 over 3. So that what? X is power 4 all over 3 all over 4 all over 3 plus c. So if you divide what you have here by 4 over 3, I think that is elementary for us to do. 3 will come up and 4 will be our denominator. So we have what? 3 all over 4 x is power 4 all over 3 plus c. So with this, we have gotten the value for that. So now you can use this illustration to solve the second one. But let's quickly do that. Let's quickly do that. Because I want you to understand this concept thoroughly well. I want you to understand it thoroughly well. Let's do that. Okay. Now the next one, 1 over x raised to power 6. The next one, 1 all over, that is integral of 1 all over x raised to power 6 dx. Come on, don't be surprised. That is very simple. Don't panic. It's very simple. What you just need to do is what? The integral of. Now, 1 over x raised to power 6 in indices. If you take this x raised to power 6, if you take it up so that it becomes what? Numerator. It's going to be what? Negative exponent. So you have what? X raised to power minus 6. Okay? Dx. That's what we're going to get. So now, you have what? X raised to power minus 6 plus 1 all over minus 6 plus 1 plus your c. Okay? So you have x raised to power minus 5 all over minus 5 plus c. All right? So if you like, what? You might rewrite x raised to power minus 5. Yes. So that would be what? That is 1 all over x raised to power 5 all over minus 5 plus c. Okay? But ideally, you can't leave it like this. You are divided by minus 5. Obviously, minus 5, it's just 1 over x raised to power 5, just like this. 1 over x raised to power 5 divided by minus 5 all over 1. So that 1 over x raised to power 5 times 1 over minus 5. It's reduced, just, I hope you are getting that. Okay? So, you now have, you can now write it this way. Let's write this way. Write it this way. Let's clean it up. Let's clean it up. Let's clean it up. Let's clean it up. So we can write, so 1 all over x raised to power 5 can be written as x raised to power minus 5. Yes. Sure, you know that. So the result will now be written as minus 1 all over 5 x raised to power 5 plus c. Why? Because your 5, x raised to power minus 5 will come down and you have this. Are you confused? Are you confused? No. Obviously. I got it from 1 all over what? X raised to power 5 all over minus 5. So I can rewrite the whole of this, if I want to write this, it's from x to the minus 5. Are you getting it now? So if it comes down, which means that it was negative before, so by the time it comes down now, it will be x to the power 5 multiplied by the 5 here. So the minus 1 will come here, and you have 1 all over 5 x to the power 5 plus c. Now the next one, I believe you can solve the next one by yourself. Woo! Let me solve it for you. Now the next one, the integral of 1 all over the square root of x raised to power 3. Now, this is very simple. It's very related to the previous one we've solved, just like this. So just all you need to do is what? You rewrite this. This one is like 1 all over x raised to power 3 all over 2 dx. Yes. According to the law of indices, the square root here will come as what? The denominator of the exponent. So which is the same thing as what? You can now write this one, what? X raised to power minus 3 all over 2 dx. Because by the time you take this x raised to power 3 over 2 up as numerator, it gets a negative exponent. So which will now be what? Which will now be x raised to power minus 3 all over 2 plus 1 all over minus 3 all over 2 plus 1. Everything plus c. Okay? So by the time you add them together, I expect you to easily solve that. You have what? X raised to power minus half all over what? All over minus half plus c. So if you bring down this one, this one is x power minus half. It's like what? Let's clean it. Let's clean it up. Let's clean it up, please. Sorry about that. Let's clean it up so that we understand how we got our result. Let's clean it up. So this is what you can. This one is x power minus. So you can go what? By the time you bring it down, it becomes 1 all over x power half. Yes. All over minus. If you divide the whole of this by minus, divided by minus half, 2 will go up. 2 will go up. It's not what times minus 2 over 1. Beautiful. So that's what? Minus 2 all over x power half plus c. You can leave it like this if you so desire. At the same time, you can say, okay, this implies minus 2 all over the square root of x, plus c, because the square root of x is x power half. All right. So we'll go to the next one. Let's go to the next one. I hope we are getting it. Am I communicating? Let me hear from you. If I'm communicating, please say yes. Type yes, please. Type yes. I need your feedback. Am I communicating? Please say yes, please. I want to hear from you. Am I communicating? Are you on there? Hello? Am I communicating? All right, okay. All right. So let's continue, please. Oh, beautiful, beautiful. God bless you. David, I can see you. Oh, Samuel, Tony, Praise, Aki, Osho, Taiwo, the one day. Thank you very much. Thank you for saying yes. Okay. So let's continue. Now, the next one says the integral of 1 all over the square root of 9 minus x squared. Okay, dx. Now, if you look at this question closely, this question looks like the integral of the x all over the square root of ax squared minus x squared. Yes, we have done something like this when we are discussing standard forms. So I would just expect you to convert your n9 to have this form. So this one would be what? The integral of, you write it all over 1 over square root of 9 would be what? 9, that's 3 squared minus x squared dx. Just fix it. Remember, the result we obtain for this as a standard value is what? Sines arc sine x all over a plus c. This is the result for this standard for our question. So that means this one will not just be arc sine. You don't need to stress yourself. Once it has that form, your x now is 3. I'm sorry, your hair is 3. Sorry about that. That's x all over what? 3 plus c. So x all over, because the x is variable, the 3 is the constant a, so x all over 3 plus c. Let's look at the last one here. Oh, it's not the last one. Let's solve this quickly. Let's solve this quickly. Okay. Now, the next one here is number 6. That's the integral of 1 all over 25 plus x squared dx. Now, this is the same thing as dx all over, a squared plus x squared. Yes, that is it. So your a squared is 25. That means you are going to split it as the square root of the integral of 1 over 5 square plus x squared dx. So that is what you want to. So you can put dx here because the x times 1 is dx. So using the result, we have a standard form here is 1 all over a arc tan x all over a plus c. So obviously, if you have a square equals to 5 square, your a is 5. So that this one will not what? 1 all over 5 arc tan x all over 5 plus c. So if you come across this type of questions in the exam, they are cheap questions, you know. Once you know the rules, once you know the standard forms, you don't have to have problems there. Okay, now let's look at the last one there. We are still, you know, illustrating our standard forms with examples. We are still illustrating our standard form with examples. Okay, now the last one says integrate sine half x squared, sine square half x dx. This is a little tricky, very tricky, very, very tricky. So I will expect us to be very, very serious here and vast. Otherwise, we miss it. Okay, what are we going to do here? Now, let's recall. Recall from our trigonometry. The concept of cos x. We want to use that. Why are we using cos x? Fine. You know, it's just like saying that this thing is just like saying that sine square x dx. Yes. Yes. But x here has been divided into two halves. So, and in our trigonometry, the one that has to do with, you know, sine square is cos. So we're not going to say what. So that's why we are picking cos x. We shouldn't have picked sine x. No, the cos x should be chosen. So we can split cos x into cos, you know, when you split this, you have what? X all over 2 plus x all over 2. Are we following, please? Are we following? Are we following? Are we following? Okay. All right. So which invariably will be cos x all over 2 cos x all over 2 minus sine x all over 2 sine x all over 2. Don't forget x over 2 is just half x. I hope you understand that. I can write sine cos half x is the same thing. Cos half x is the same thing. You multiply half by x is x over 2. So you can write it like that anyway, if you like. So it's the same thing, half x. So that is why you are going to have what? Cos square half x minus sine square half x. Please, are we following? Beautiful. Now, there is a concept in trigonometry. There are, in addition of our angles, our sines and trigonometry, that says that sine square x plus cos square x is equals to 1. So the same thing applies to half angle formula, because this is a half angle formula. Sine square half x plus cos square half x is equals to 1. Beautiful. Beautiful. So now, don't forget, our target is to get the integral of sine square half. Sine square half x. So we need to remove cos square half x eventually here. So by the time we now say, okay, let's make cos square half x the subject of the formula. So we have cos square half x will be equal to 1 minus sine square half x from here. So with that now, we can put this value, equation 2, that we have obtained from here now, into equation 1. So substituting equation 2 into 1, putting equation 2 into equation 1, will give us what? So equation 2 says, I've cleaned equation 2. Unfortunately, I've cleaned that. I think we have, okay, said cos 2x is equal to cos square half x, yes, minus sine square half x. Beautiful. So I've regained it. So now my cos square half x is now what? 1 minus sine square half x minus sine square half x. So that is my cos 2x. So this one will be what? 1 minus sine square half x minus sine square half x. It's like saying sine x minus sine x. That is 2 sine square half x. That is our cos 2x now. Okay? Now let's make sine square half x the subject of the formula. So it comes here and becomes what? Minus will come here and become 2 sine square half x, is equals to 1 minus cos 2x. I hope you are following. Please, let me see your comments. Are you following, please? Are you getting it? Hope you are not confused. Are you following, please? Are you following? Okay. Now, in this case now, sine square half x will be equal to 1 minus cos 2x all over 2 if you divide both sides by 2, which is the same thing as what? Half, minus half cos 2x, because you are dividing this 1 and this by 2. So you split it like that. So which implies that the initial problem of sine square half x dx is now the same thing as what? Half minus half cos 2x dx. Yes, we have replaced it. So it will be easier now to integrate, because ordinarily to integrate square or any exponent that is more than 1, to integrate directly in integration is not easy. So you have to split it in such a way that the degree of that function will become 1. So that's what we have just done. We have simplified into a form that it can be easily integrated. So now, from integration, there's a principle that says that because integral sign is a linear map, so you can split it and say the integral of half dx, if you like, minus the integral of half cos 2x dx. Yes. Okay, you can split it. So, which is going to be, now there's a rule that says that when you have a constant, you bring it out. So you have half the integral of dx minus half the integral of cos 2x dx. Beautiful. So that will give us what? Half. If you integrate the x, note it will be x. The x is a differential coefficient. It's like saying integral of 1 dx. Okay, that's the meaning of integral of dx. So, and I told you, if you could recollect when we started, I said this integral will cancel this d. So by the time it cancels it, you have only x left. Okay. Now, before you had your constant, you must have finished everything before you now had your constant. So that was minus 1 all over 2. Now, we are going to get there, but before that, let me quickly chip in this. Whenever you remember when we say that, when we first started, we started with what? We said the integral of cos x gave us what? Minus sine x plus c. Oh, sorry about that issue here. So that's a slip of tongue, is sine x plus c. Yes, sine x plus c. So now, but this time around now, we are talking about the integral of cos 2x. So you'll be expecting that, you'll be thinking that it should be sine 2x plus c. That will be wrong. No, that's not standard. What you just need to do is, you first of all divide this particular function by the coefficient of x. And the coefficient of x is 2. So you say 1 all over 2. Now, you now assume that 2x is now x. And whenever you integrate cos x, you have sine. So you have sine 2x plus c. Okay? So you can try it. If I say, what's the integral of cos 7x? You have 1 over 7 sine 7x. The integral of cos 20x, 1 over what? 20 sine 20x plus c. So this one now become what? Times 1 all over 2 sine 2x plus c. Okay? Beautiful. So with that now, the final answer will be, our final answer will now be 1 all over 2x minus 1 all over 4 sine 2x plus c. So that solves the problem. So with this, we have come to the end of that particular problem. I think you have clearly understood how we get that particular problem solved. So how we get that problem solved. Now let's look at more illustrations. So we are done with that. Now we want to discuss 5 important rules. But in this case, I will just discuss them briefly because we have mentioned some of them indirectly in our examples. But we're going to discuss the major ones that we need for further application in what do you call it, in integration. So we want to talk about 5 important rules. All the rules are important, but these ones are special. They are special rules. So the first one is rule 1. The first one is rule 1. What does rule 1 say? Rule 1. Now, rule 1 says that the integral of a sum of a finite number of functions is the sum of their separate integrals. Again, the integral of a sum of a finite number of functions. Let me write it. Let me write it first. The integral the integral of a finite sum of functions is the sum of their separate integral. Is the sum of their separate integrals. Their separate integrals. Okay? Now, how does that apply? Beautiful. How does that apply? The integral of a finite sum of functions is the sum of their separate integrals. Let's look at an example to buttress this. That's rule 1. Suppose we have, let's use a better marker here. Suppose we have the integral of x squared plus sine x plus the square root of x all dx. Yes, you go observe that. Look at the rule 1. Say the integral of a finite sum. Are we following, please? Of functions is the sum of their separate integrals. This is a finite sum of functions. We have 3 functions here. We have algebraic functions, we have trigonometric functions, we have we have square root functions. Sorry. So now we have 3 functions. So the integral of all these 3 functions will not be what? Will not be solved by separately what? Separately finding their integrals. So that will be what? The integral of x squared, dx plus the integral of sine x dx, plus the integral of the square root of x dx. Yes, so you split them. That's the rule. That's what the rule says. Okay, now let's look at how this can be solved. You now separately solve them. X squared will be what? X raised to power 3 all over 3, because you add 1 to these 2 divided by the result. Then plus, now sine x, that is what? This is sine x. Now you are integrating. That will be minus cos x. All right. Then plus, now this one is root x. Root x is like x raised to power what? Half. Yes. And when you have that, you have what? You add 1 to that half. You have x raised to power half plus 1 all over, half plus 1 is 3 over 2. I hope we got that. Beautiful. So plus c. Yes, plus c. So now let's quickly finish that by giving us the results. If we had half plus 1 is 3 over 2. So you can now say what? You can say x raised to power 3 all over 3 minus cos x plus, now dividing these whole numbers, x raised to power 3 over 2 by 2 will go up, 2 over 3, and x raised to power 3 over 2 plus c. That solves the problem. That's the result of that. Now let's look at another one. And because of our time, okay, let's quickly look at another one before we go to root 2. Look at this question, because it's interesting. This question is interesting too. Let's look at it. The integral of exponential x minus cos x dx. Yes. So like I just said now, because the rule says that when you have a finite sum, the integral of a finite sum of functions is equals to the individual sum, the individual integral of the functions. So now, what this one means is the integral of exponential x dx. Yes, just separately do it. The integral of minus cos x dx. It's as simple as that. So now you integrate exponential x dx. I told you in our standard form, it will be exponential x. That is it. Now minus, when you integrate cos x, it will be what? Sine x plus c. That is it. It's as simple as that. You can see that this thing is interesting and simple. If you understand the principle very well, you will even later say that you enjoy integration more than differentiation. Yes. So let's go to root 2 quickly. Let's go to root 2 quickly, please. Now, root 2 says a constant factor may be brought outside the integral sign. We have done something like that this morning, this afternoon. Root 2, a constant factor may be brought outside the integral sign. A constant factor may be brought, you know, outside the integral sign. Integral sign. Oh, let me chip in something. If you are able to wait to the end of this class, there is going to be a giveaway for you. I can assure you, if you are able to wait to the end of this class this afternoon till the end of the class, I will ensure that you have a giveaway. Okay. Now, under the giveaway, the terms and condition will be explained to you when we actually get to the end of the class. Okay. Now, the rule 2 says a constant factor may be brought, out, may be brought outside the, outside the integral. This is what this thing is outside, please, the integral sign. Okay. Now, let's follow the example. The integral of 6x raised to the power 4 dx. Very simple. The constant factor here is 6. So just bring it out. 6 integral of x raised to the power 4 dx. Okay. So now you evaluate x raised to the power 4. You have what? 6 into x raised to the power 4 plus 1 all over 4 plus 1 plus c. And that will give us what? 6 x raised to the power 5 all over 5 plus c. Very simple. So another example there, example 4, is the integral of 5 all over u du. Beautiful. Now bring your constant out. You have 5 integral of du all over u. You can see how we beautiful. Remember, sometime in our standard forms, dx all over x, we said is what? Log x base e plus c, which is ln x. Okay, so here now you can just write that would what? 5, which is outside, log u base e plus c. The same thing. Very simple. So that is that about that. Let's look at another rule, because this other one is similar to another rule. Okay, the other rule says, we have also done that, but let's do it. We have, cited an example to illustrate that before, but let's talk about rule 3. Let's talk about rule 3, please. Let's talk about rule 3. Now, rule 3 says, rule 3. Okay, I think let me write my 3 this way because I'll be using numbers. Yes, rule 3 says the okay, sorry about that. Okay, the addition of a constant, to the variable makes no difference. Makes no difference. The addition of a constant to the variable makes no difference to the form of the result. Let's check. Is that true? Let's check. For example, the example there, let's look at e.g. the integral of cos 5x dx. I told you we have done something like this. Since 5 is a constant, you divide it by 5, 1 over 5. Then cos x is sine x. Sine 5x plus c. That's that. Look at this one as well. The integral of exponential minus 2x dx. Now, this is interesting. This is very, very interesting. I told you that the integral of exponential x dx is exponential x plus c. I told you. Now, this one is integral of exponential minus 2x dx. It's different from this. This one has a constant, it has a coefficient of x. This one has only 1 as the coefficient. So, since a constant factor is there, what you just need to do when you have kind of questions like this, just say minus 1 all over 2. This, you find the inverse of this. It's like 1 over minus 2. So, minus will come up. So, minus 1 over 2, then exponential 2x plus c. That's all. That's all. It doesn't make any difference. So that is that about that for that. Let's go to rule 4. 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 What does rule 4 say? What does rule 4 say? Multiplying the variable by a constant makes no difference to the form of the result, but we have to divide by the constant. Okay. Multiplying the variable by a constant makes no difference. Makes no difference to the form of the result, but we have to divide by the constant. We have to divide by the constant. This is very similar to rule 3. So example, integrate exponential 3x minus 4 dx. Now, it's very similar to the other one. So what you just need to do is, the trick is here. Let me just tell you the trick here. The trick is differentiate this exponential 3x minus 4. If you differentiate it with respect to x, you have 3. So now, inverse of that 3, 1 over 3 exponential 3x minus 4 dx. That is plus c now. That's all. It's like integrate that exponential 3x dx. You know, it's the simple rule is just that 1 all over the exponent here, exponential 3x. But in some cases, you may have more, you know, it might not be linear. It could be algebraic. So you should know the principle. Just differentiate. That's all. Now, the next example, integrate dx all over 2 minus x. Good. Integrate dx all over 2 minus x. Now, please look up. You have to be very careful here. This one is not as easy as it looks like. But I will tell you that it's very easy. Okay? Don't panic. Now, look at 2 minus x. Differentiate this 2 minus x. You're going to get minus 1. Okay, let me remind you. Suppose I say y is equal to 2 minus x. And I want to find the y dx. You know, the y dx with respect to x will be, this is 0 because it's a constant, minus 1. Yes? Now, this minus 1, you know, the other time I said the integral of dx is like saying integral of 1 dx. Yeah? So if that minus 1 comes up, that means we're going to have minus dx. So we are having minus 1, minus dx. It will not be looking like indeed the integral of dx over x. And because, yes, because when I integrate this, anytime you integrate a function, are you with me now? Sorry, you differentiate a function and the result gives you the value here. It means that the result will be log what you have as denominator. Okay, look at dx all over integral of dx all over x. If you differentiate x, you have 1. That 1 is here. That 1 dx. So, and we write the result is log ex plus c. That's the trick. That's the trick. The integral of dx is the same as the integral of 1 dx. So if you differentiate this x, you get 1. So that 1 is what you have there. So and the result will just be what you have as denominator. So if you differentiate this one, you have minus 1. So that minus 1, you know, this ordinarily, we are having 1 here, but we will obtain minus 1. That means 1 will be put here as a constant. Okay? 1 will be put here as a constant. All right. Because they say multiplying the variable by a constant. So minus 1. Can see? Because this is plus. By the time you multiply the result you have here by minus 1, it forms what we have there. So we have got minus ln exponential 2 minus x plus c. Because by the time you get minus, this one is originally plus. So I'm multiplying it by minus, it makes it look like what you have as your denominator. Okay, I think you understand that too. Now let's look at this funny one. This one is very funny. You are getting closer to more technical ones. We are getting closer to more technical ones. Please, I hope we are not tired. Are we getting it? Please, are we enjoying it? Please, am I communicating? I want to hear your comment, please. Are you there? Are you still there, please? I'm waiting for your comments. Okay. All right. Beautiful. Beautiful. You are still there. That's very good. That's very good. Keep it up, please. Now, let's look at this another example. The integral of the square root of 5x plus 3, raised per half. Yes, raised by half. Sorry, the square root of 5x plus 3 dx. Sorry, that's the question. Square root of 5x plus 3 dx. So now, what do we do? What are we going to do here? You can see that this one is like a twin question. Why? Because it has a square root and it has a linear expression. So it's like square root function, linear function. So you write it like 5x plus 3. Then the square root here will be raised by half dx. Okay? So the next thing now is, as usual, if you have x raised by half dx, it will be what? X raised by half plus 1 all over what you have here, 3 over 2. Now, but remember, you are having a constant before your variable x. So that means you first of all divide by that constant. That is the rule. Okay? Now, what the next thing is to add 1 to it. You have 5x plus 3 raised by half plus 1, then everything over 3 over 2. Yes. So if this one moves around, so it becomes 1 all over 5x plus 3 raised by 3 over 2 all over 3 over 2. So when you are divided by 3 over 2 will come up and you have what? 2 all over 15, 5x plus 3 raised by 3 all over 2 plus c. You are wondering, beautiful. You originally have 1 over 5 here. Times by the time you invert 2, it will be 2 over 3. You are dividing the whole of this. So 2 will go up, 3 will be retained. So 2 times 1 is 2 over 15. So, and you write this. And if you want to change this one to the version of this, you can say 2 all over 15. Now the square root of 5x plus 3 raised by 3 plus c. So because that is that about that. Okay. Now let's look at another one. Okay, this time around, let's look at the beautiful one. We are moving closer and closer to more technical ones, to more technical examples. We are moving closer and closer to more technical examples. Please don't be tired, don't be weary. Now this example says, it's a very good example. These are likely exam questions because they are very, very technical, but they are simple. They are very technical, but simple. They will be difficult for students that are lazy. Why it will be easy for students that are very, very hardworking. Now, if you look at this expression somehow resembles the x all over a squared plus s squared. Somehow, it resembles somehow. Why do I say it resembles somehow? Because you have s squared. This is an algebraic expression. So that means that this will give us an idea that can we make this one a square also? Can we get a complete square from this one so that it will now look like this? Since we are having x squared and s squared, can we do, what are we going to do? So it's so that we have a squared like like the standard version. So what we just need to do is that take your denominator. The denominator is x squared plus 4x. Now using completing the square method, completing the square method, to evaluate x squared plus 4x plus 13. Okay. And when you want to use complete square method, is what it simply means is that you had half of the coefficient of the second term. The square of the half rather. You are going to find the half of this 4. The square now will be added. So you have what? That will be x squared plus 4x plus half of 4. That's 4 over 2. It's a constant square. Yes. If it had been 5, you say 5 over 2. If it had been 9, you say 9 over 2. So half of this coefficient, the square of it, will be added. So when we add that, we're going to have what? We're going to have x squared plus 4x plus 4 over 2 is 2. Yes, 2 squared is 4. Are we together? So that means that this thing will give us this. Okay. But from here, we have x squared plus 4x plus 13. Please try to understand it too. Try to understand it. We have x squared plus 4x plus 13. Now with this method, we have gotten 4. What happens to 13? Nothing. So what you just need to do is, what will you add to this 4 that it make you to have your 13 here? That is it. Okay. So that means you can have the x all over x squared plus 4x plus 4. Then plus, what are we going to add to this 4? So that everything will now be like this. 9. Yes. Yes. So which means the integral of dx all over. Now, this is now a complete square. Yes. Because that's the essence of doing that is to get a complete square. And which means that x squared plus 4x plus 4, if you factorize it, it will give you a complete square. So don't stress yourself. Just pick the first what do you call the term here is x squared. What's the square root of x squared? Is x. Don't forget what the square you added there is a positive sign. It's not minus. If you had minus, it will be minus there. But it is plus, plus what? Plus 2. So plus 2 square. Yes, that's it. So that means x plus 2 square has represented this now. That's the logic. The square root of this is x plus the square root of this. I would have picked this one directly and get right 2. But because I have to consider how I started here. If it had been minus here, this one will be minus. But because it was plus, I know that the square of the square of minus sign is plus. I know, but since I use plus here, that's why I'm using plus. If it had been, if this plus has been minus, I'll write minus 4 over 2. So this will be minus 2. But because it was plus, so I use plus. Okay. Then plus, what do we have left here? 9. 9 is what? 3 square. Of course, 9 is 3 square. How do you see it now? Beautiful. So, I can see that this one now looks like, it has now looked like this. Yes, it has looked like that. So our A is now what? 3. Why our X is now X plus 2. No matter. So let's complete it. Let's complete it. Let's complete it. So by our standard form, so we have what? By standard form, we have 1 all over A arctan x all over A plus C. So our A is 3 arctan x, our x is now what? X plus 2 all over 3 plus C. So that is that about that. That is that about that. That is that about that. Now let's look at another rule. Let's look at the last rule so that we leave the rules and move forward. Let's look at another rule. Beautiful. This is another rule. I hope you have it in mind that you are going to stay to the end of the class so that you'll be able to have my giveaway. So if you don't stay to the end of the class, it will be difficult for me to give you anything. Okay. Now rule 5. I think I've been writing numerals. Numbers. The integral of a fraction. The integral of a fraction whose numerator is the derivative. Wow, I've solved something like this, but let's do it. Is the derivative of its denominator. Denominator is the logarithm of the denominator. What a statement. What a statement. Let's look at the example. Example will let us understand this statement better. Integral of 4x cubed minus 1 all over x raised to power 4 minus x plus 2 dx. Now, what is the meaning of this statement? The statement says that the integral of a fraction, this is a fraction, this is a rational number. Our integral is a rational number, it's a fraction, whose numerator is the derivative of its denominator. That means we have to differentiate the denominator. So if by the time we differentiate the denominator, the result we get is its numerator, that means the answer to that problem is the logarithm of the denominator. It's not funny anyway. Let's try that. Let's differentiate x raised to power 4 minus x plus 2. Yeah, let's differentiate it. In our differentiation now, 4 times 1, 4s cubed. If 4 times 1 is 4, now subtract 1 from 4, 3. Then minus, when you differentiate x, you get 1. When you differentiate plus 2, you get 0. You can see that it's giving you what? 4s cubed minus 1. So what you have here is what you have as the numerator. I hope you can see that. So that's what the statement is saying. So your answer directly, without wasting your time, is just what? The logarithm of that denominator. That's log base e of x raised to power 4 minus x plus 2 plus c. Sefinek. That is that about that. Okay. Let's look at another one there. This one is what? Very similar to this, so simple too. It's not stressful. 3x squared all over x cubed plus 1 dx. Now, it's a rational number, fraction. Differentiate what you have here. Differentiate x raised to power 3. That will give you what? 3 times 1, 3 x squared. Because by the time you subtract 1, you have 2. Then plus, when you differentiate plus 1 plus 0. So you have what? 3x squared. And 3x squared is what you have as your what? As your numerator. 3x squared is what you have as your numerator. So that means that the result will be what? Log exponential x cubed plus 1 plus c. That's log e, which is ln s cubed plus 1 plus c. So I think that is that. Let's look at another case. This one is a special case of this. We just have to do it. It's a special case. What of if sometimes you differentiate the denominator and the result is not what you have, but it has something you can put there to make it equal to it. That's what we are going to do now. You have something. Okay, let's look at it. So simple. This is a special case. Integral of s plus 1 all over x squared plus 2x plus 5 dx. Now, let's apply that rule. Let's differentiate what we have in our denominator. By the time you differentiate it, you have what? You're going to have 2x, because 2 times 1 is 2, then minus 1. 2x plus, when you differentiate 2x, you have 2. This one will be 0, so you don't need to write plus 0. Now, you can write this one as 2 into bracket because 2 is common. I hope you understand. Beautiful. I hope you understand. So that means that, but unfortunately, what you have here is x plus 2. I'm sorry, x plus 1 is what you have there. But don't you know that if you multiply what you have with your result here by half, you'll get this. Yes, that is, let's try. Half times 2 into bracket x plus 1. 2 will cancel 2. So you have 1. So that means just multiply and say this one will now become half into the integral of, that's the logic. Now you change this one to 2x because what we are having now is 2x. 2x plus 2 all over x squared plus 2x plus 5 x. Are you shocked? This is the same thing as this. this thing is the same thing as this. Okay. So that now what? Half. Because half is a constant outside. So when you differentiate this now, you definitely get this. log exponential x squared plus 2x plus pi plus c. That solves the problem too. That solves the problem too. So that solves the problem too. Please, are we following? Are we following? Any problem, please? Please, any problem, please? Is there any problem? Hello? Are we following? Please, I want to hear from you. Oh, okay. Okay, thank you. Thank you very much. Thank you very much. Thank you very much. Thank you. So, let's solve this interest. This one is interesting. Let's solve this interesting question. I think there are two more questions there I want us to solve. Yes, I want us to solve them. I want us to solve them. Yes, it's interesting. I want us to solve them. These are likely questions. They are simple, but they are technical. They might confuse student who is not careful enough. They might confuse student who is not careful enough. Yes, yes, yes. Now, look at this. What a very funny question. Integral of dx all over x log x base e. Do you know that you can write this as the integral of dx all over x all over log x base e? Are you shocked? Because by the time you divide dx over x by, let's try dx all over x divided by log x base e is the same thing as dx all over x times 1 all over log x base e. So you are going to get this. So that will be dx times 1 is dx all over x log x. So you can see. Now, what a funny question. If you can still vividly remember, if you differentiate, if y is equal to log x base e, if you differentiate this function, you are getting 1 over x. You remember that at all? Are you sure? And don't forget that this one is now like what? It's like 1 over x dx. That's the meaning of this one now. All over log x base e. That's the meaning of this. This dx over x is because 1 times dx is dx all over x. So now that we differentiated this denominator and we are able to get 1 over x, which is the same thing that we have here. And so what were we saying? So the answer would have what? Lane of the log of, which is normal, of log x base e again, or c. Oh, no, don't be confused. Come on. Now, dx over x can be written as 1 over x dx, all over log x base e. So, if you differentiate log x base e, I've just told you, remember in differentiation, you have 1 over x. Fine. And since this rule says that anytime you differentiate the denominator and it gives you the result of numerator, you are going to write the answer as lane of the denominator. So first of all, write lane, which you have been writing before. Then now, and unfortunately, also we have lane x base e. So plus c. So that is that about that. That's that about that. That's that about that. That's about that. That's that about that. So might be shall we continue? Shall we continue, please? Shall we continue? Please, I want to hear from you. Shall we continue? Shall we continue by going to MTS 106? Okay, you don't understand. You don't understand. Okay, no problem. Now look at the question again. Look at the question. Okay. I will stop here. Now I will stop here for you. So we move to MTS 106. This is the question: dx all over x log x base e. You can write this as this now. If by the time you bring your x here as a numerator for this function, for this constant, this differential constant, it will be written like this. I showed you. Dx over x all over log x base e. Of course, see the way I've shown it there. Dx over x divided by. If you divide this by this, look at how it's going to be. Dx over x multiplied, because divided by this means 1 over of this. So if you multiply back, it will give you this, which is going to give you this. Look at it now. Dx times 1 is dx all over x times log x base e. So now, and the rule says that if anytime you differentiate, and I told you now dx over x is the same as 1 over x dx. Yes, of course, beautiful. Now, and the rule says that anytime you differentiate what you have as denominator, if it gives you the value of numerator, you write ln of that denominator. So the ln is log x, log base e of what you have as your denominator. So, since you are saying that we should move to MTS 106. Let's go to MTS 106 now. But I think by popular demand, you are saying that we should go to MTS 106. Do we have MTS 106 here, students here? Please I want to hear from them. Any MTS 106 here, please. Any MTS 106? Let me just say yes, I want to hear. Any MTS 106 student there? Aha, beautiful. They are here. So I wouldn't want to shortchange them because it was an agreement that I will also teach MTS 106. And since MTS 102 students said they are a little bit tired, that the class should not continue. But don't forget, if you don't wait till the end of the class, you will not be opportune to have my giveaway. Yes, that's the rule. If you don't wait till the end of the class, so you will not be privileged to have my giveaway. What do you mean by no? What do you mean by no? Okay, sir. So move to MTS 106, or sit do a little thing on MTS 102. Okay. Now let's quickly go to MTS 106, and that's going to be conic sections. Anyway, whether you are doing MTS 106 or you are doing MTS 102, both of them are useful for you. But I would advise that you partake in these two, because you will talk about you say 102 should continue. Okay, how many of us want 102 to continue? Please, let's turn it to vote. 102 should continue. 102 should continue. MTS 102 should continue. Are you saying yes now? You can't see any. That should be network from your end there. That should be network from your hand. There's nothing happening here. I didn't touch it. Now let's make it let's turn it to a ballot. If you are in support of continuation of MTS 102, please say yes. Yes. If you are in support of MTS 102 to continue, say yes. Say yes. I'm counting. 102 should continue. Okay. Should continue, please. 102. So that means MTS 106 they are not here at all. Only very few of them are here. Only very few of them are here. So we should continue with MTS 102. Okay. All right. Okay. So, well, if in the course of this now, if we have students who wants 106 to take off, then we will know. Okay, let's do more. Let's balance it. Let's do more of let's do about 30 more minutes lecture for 102. So after that, now I will switch over to 106, please. Let's have 30 more minutes lecture for 102. After which we now switch to 106. 106, don't worry. It's a promise. We will continue. We will actually satisfy you too. Don't worry. 102, please. Let's quickly do this so that we allow 106 to take off. Let's quickly do this so that we allow 106 to take off. Now we have exhausted all the rules. Let's look at a few more examples. Let's look at this is an example, but it's an exercise in this test. Let's solve some problems, tutorial problems. Let's solve some problems now. One we have in evaluate the integral of 2x plus 3 raised to power 10 dx. Now evaluate this. This is very simple. We have done something very close to this. I told you. In fact, this kind of question shouldn't take you 5 seconds to solve. Yes, if you know what you are doing, you shouldn't use 5 seconds to solve this question. 5 seconds. First of all, the constant of your variable here is 2. So divide by 1/2. Then add 1 to your numerator here. That is 2x plus 3 raised by 11. Then all over that 11 again. That's all. So that will plus c. So that will give you what? 1/22. 2x plus 3 raised power 11 plus c. So that's the answer. That is not it's not special. That's not special. Let me look for another aspect that we need to discuss. Let me look for another aspect that we need to discuss. We have exhausted this. Let's quickly go to another aspect of the course that we need to discuss. Let's go to another aspect of the course that we need to discuss, please. Okay. So we are through with 48. Now let's go to application. I think I have an example. I'm coming. Before we go to application, there's an example here that I want us to solve. Yes, good. Oh, good. This is beautiful. Yes, let's solve this example. Let's solve this example, please. Before we now move to application of, integration. Let's look at this example. Suppose we are given this kind of question in the exam. Example, find y in terms of x if the square y all over the x squared is equal to 6x minus 4, and further y is equal to 0 when x is equal to 0, and the y dx is equal to 3 when x is equal to 0. This is very standard. It's a very standard question. Very standard and likely question that could be asked in the examination. Yes. So let's look at this. I wouldn't be happy if we omitted this question, honestly, because it's a very standard question. Now, find y in terms of x if the second degree of differential coefficient is equal to 6x minus 4. I think that's it. Yes. And further, y is equal to 0 when x equals 0. Two things are involved there. Another condition is dy dx is 3 when x equals to 0. So we have to consider those initial, let's call them conditions, not really initial conditions anyway. So we have, the square y all over the x square is equal to 6x minus 4. Remember, the question says we should find y. And we have the square y, second degree of y. Second degree of the linear coefficient of y. So what we need to do here is, let's look at this now. Let's cross multiply first. This one will be what? The square y, or better still, well, there are two approaches. The x square is equal to, okay, the best way is this. Let's reduce the degree. That would be better. Instead of, it will be confusing if we have to cross multiply first. Integrate both sides. Integrate both sides. That is, integrate both sides gives, or integrating both sides gives, whichever one. You have what? By the time you integrate, it means that this integral of the square y all over the x squared is equal to the integral of 6x minus 4. That is the meaning of integrate both sides. So which means the square y, one d will disappear. You have the y all over the x is equal to the integral of 6x minus 4. Okay? Now, with this now, you can cross multiply. It will be easier now to cross multiply. It will be easier now to cross multiply. If the picture is blurry there, that means that could be a network problem. It's not from here. That could be a network problem. So the y will now be equals to the integral of 6x minus 4 dx when you cross multiply. So, which invariably means, now, don't forget, we are to integrate the value we obtain here. So we are integrating as what? As the y equals what? 6x raised power, you are integrating 1 plus 1 all over 2 minus 4x plus c. Yes. Okay? I hope you understand. This will be because if you integrate 4 dx from the knowledge we have had so far, is a constant, you bring it out 4 integral of dx. And when you integrate dx, it is x. So 4 times x, then plus your constant. That's how I got this. Minus 4x plus c. So this will give us what? 3x raised power 2 minus 4x plus c. That's our dy. That's our dy. That's our dy. Don't forget, that's our dy dx. That's our dy dx. So our dy dx is because, we multiply out by dx before. If I bring it down, it will change. You understand? So that's our dy dx. Ordinarily, I could have just written dy dx equals to the integral of 6x minus 4. So by the time I integrate this, I will have what? 6x raised power 2 all over 2 minus 4x plus c. Yes, this is standard. I could have done it that way, but this is another way of doing it. Okay. Why do I bring my dx here? Because I've not really reduced the differentiation. It's a second derivative, so I have to come back to, when I get first derivative, I will come back to or just a function without a derivative. So that's it. So if you don't understand this, it's simple as this. Okay. So now I've brought this back, which is the same thing. Now the question now says that the y dx is 3. So you have 3 is equal to, when x is 0, that is 3 of 0 square minus 4 times 0 plus c. Okay? Now, which means 3 is equal to 0 minus 0 plus c. So that means what? 3 is equals to c. So if 3 is equals to c, what is that? Means by substitution now, that implies that the y dx is equal to 3x squared minus 4x plus 3, because we have gotten c to be c. That means our constant, the arbitrary constant we are adding here is 3. The arbitrary constant we have added there is 3. Now, having done that, don't forget, the question says we should find what? We should find y. Now we have gotten this, we can now say that implies that this now implies the y is equal to 3x squared minus 4x plus 3 dx. So integrating both sides now, you have the integral of the y is equal to the integral of 3x squared minus 4x plus 3 dx. So that what? D will cancel integral. You have y is equal to 3x 2 plus 1 all over 3 minus 4x 1 plus 1 all over 2 plus 3x plus d. You can't use c again. Anytime you are integrating indefinite integral, you must always add a constant. So you must add another constant here now, because you are integrating a new function. So this one, what? Y is equal to 3, we cancel 3 here. X raised to power 3 minus 2x raised to power 2 plus 3x plus d. Yes. And the question says, when y is equal to 0, x equals to 0. Now putting x to be 0, when y equals to 0, x equals to 0. Now gives y 0. 0 equals to 0 raised to power 3 minus 2, 0 raised to power 2 plus 3 multiplied by 0 plus d. Please, are we following? Can we see that? Okay, okay. So if we can see that, now the next thing now is to get what D stands for. What does our D stand for? That's the next thing now. Okay, that means we have 0 equals to 0 minus 0 plus 0 plus D. So our D means what? D is equals to 0. So therefore, Y is equal to S cubed minus 2x squared plus 3x plus 0, which is what? Y equals to S cubed minus 2x squared plus 3x. So that solves the problem. So that solves the problem. That solves the problem. That solves the problem. Okay? Okay, that solves the problem. So let's look at one more example before, if I thought we are going to switch to MTS 106. MTS 106. Before we go into that, let's try to solve problems in applications of trigonometry to geometry and mechanics. Can we still quickly do this? Can we still quickly do this? Or we should call it a day for MTS 102? Should we call it a day for MTS 102, please? Okay, we should call it a day for. And it's necessary for us to find the constant because the question wants us to find the value of y. And the question gave us the square y, the x square. We are moving from the higher degree of y. So the question wants us to come down. Y differentiation increases, functions, integration will reduce it. So, well, from what you have just said now, you said we should stop here for, for MTS 102. Now, MTS 106, are you still there? Are you still there, please? Are you still there, please? I want to hear from you, please. MTS 106, are you still there? If you are still there, I want us to continue. Please let me know. Please, I'm waiting. MTS 106. Please, I want to hear from you. Are you still, should we continue? Well, okay. MTS 106. I'm ready for you. If you want us to start now, please. Okay, very, very good. So MTS 106 now we are starting. We are starting, please. In this case, we are going to look at conic sections. Conic sections. Let's look at conic sections. Okay. MTS 106, we have what we call conic section. That is the area your colleagues gave to me as a difficult one. Conic sections. Now, you see, conic sections are sections that are derived from the generation of, a plane with respect to a cone. So when there is an intersection between a plane and a cone, you have what we call conic section. Take for example, suppose we have this as let's say this is y-axis, this is x-axis, and you have a kind of intersection running through the horizontal here, through the origin, and the same thing coming here, running through that center. So we have what we call a right circular cone. So we have this. So the intersection of a plane, this is what we call nape. We call this one nape. Call it nape, and this is a right circular cone because the intersection, the plane intersects the cone at the origin, and you have your napes. Okay, called napes. Now there are actually 4 types of conic section. Of, let's say, basically we discuss 4 objects in conic section. We have the hyperbola, we have the parabola, we have the cycle, and we have the ellipse. So now we are going to look at a parabola first. We're going to look at parabola first, after which, although the time might not permit us today to look at others, because parabola itself is very, very voluminous, but we are still going to talk. We are going to talk actually about the major things that are important for us to learn in parabolic functions. So Now let's look at parabola as a case study of conic section. This conic section has been in existence for ages, and a lot of researchers have come up with different results concerning the intersection of planes with cones. So we start with parabola. Let's start with parabola. Let's start with parabola, please. Let's start with parabola. Parabola. Now, what is a parabola? What is a parabola? Before we can define a parabola, we need to discuss what we call the locus. The locus of a point. Now, the locus of a point, say P of x, which moves so that the ratio of its distance from a fixed point S, which is called the locus, which is called the focus, to its distance from a fixed straight line, let's say ZQ, the directives, is a constant thing. That is, it's constant. You know, it's a constant factor. It's constant. That is, it has what we call eccentricity. It has the constant E. That is the ratio of the locus can be defined as the ratio of the distance between the focus, let's call S the focus, and fixed straight line L is constant. That ratio is called eccentricity, E. So eccentricity determines the nature of conic section. If the eccentricity of a conic section is 1, that means that conic section is a parabola. If the eccentricity of a conic section is less than 1, that means it is an ellipse. If the eccentricity of a conic section is equal to 1, that means that conic section is a circle. But if the eccentricity of a conic section, is greater than 1, that means it is an hyperbola. So all these are things you actually need to understand, in conic section. Okay. Now, I said the locus of a conic section actually determines the eccentricity. So if eccentricity is equal to 1, you have parabola. Like I said, if it is less than 1, you have ellipse, and if it's greater than 1, you have hyperbola. So a circle is not really regarded here as a conic section, but then it has some similarities with locus of a point. Because if you draw a circle now and you locate the center of that circle, any point you draw from that center of the circle is a locus, because it's going to have the same radii with all other points on the circumference of the circle. So let's look at a diagrammatic representation of a parabola. Let's look at a diagrammatic representation of a parabola. So let's have something like this. This is our vertical line, y-axis rather. We have, this is x. So let's say that we have, this is the locus now. Let's say this is our locus. So let's draw a line perpendicular to the vertical axis and call it L prime here, and call this one L. And let's extend this. So let's call this point. Let's call this point the focus. It's a fixed point, and the coordinates of this focus, it has coordinates x to be a and y to be 0 at this point. Okay. Now let's call this point. The point of the locus is s, y. It is at that point that we draw a line that runs through the focus of the parabola. So let's call this point, call it P, and let this join this. Let's join it. So we now draw, let's say we have a vertical line here that's also parallel to. So the locus runs from here to here, and it's perpendicular to another point here. Okay? And so we have, let's call this point Q, and call this one M. This is just for illustration so that you understand better. Let's call point 0, and this is the center of the origin, center of the XY axis. Okay, so with that, we've been able to show a representation of, this is called a parabola. You can see this point P, that's X and Y coordinates points, and it is that point that is called locus. There's a line that is drawn to run through this, and so that PS will be equal to eventually PM. You will see in the course of this. So this is the center of a parabola. Now, this is drawn to give us an idea of how a parabola looks like. So now let's xz let xz be the line through the focus that is perpendicular, that's the symbol of let me shorten out, perpendicular to the directrix. Directrix is a line on the parabola. This is directrix. You can see that this directrix is perpendicular to the x-axis here. This is the x-axis. Okay, you already know that. So let SO be equals to OZ. Let SO be equals to OZ. What do we mean? Now, if actually we have XO to be equals to OZ, we can see that it actually states that this is a locus. Because a locus between 2 points, suppose I have this point A and B. The locus of point A and B is the midpoint of A and B. So if you put a point here and you draw, it will just, so the distance from this point to this point is the same as the distance from this point to this point. So if this is the locus of point XY and it runs through midway of this, it means that PM is equal to SPS or SP. So the directrix ZQ, our ZQ is the directrix, is the line X equals to minus A. That is our directrix. Our directrix is line X equals to minus A. Okay? Now, if P of S comma Y, let me claim this. I don't want to claim the diagram because we are still going to discuss some of the things there. We're going to discuss some of the things there. If P of S comma Y, which is the locus point, is any point on the locus, is any point on the locus, beautiful. And what happened? PS will be equal to PM, beautiful. Let's look at this. If P is any point on the locus, PS will be equal to PM, of course. So the distance between PS and PM will be the same thing. Good. Now, therefore, this is where we are now going. This is where we are going. Suppose from this statement now, from this statement, let's see if we can get a red pen. There's no red pen. Let's use a green one. From this statement, we said if this is the point, fine. That means that here we have X. Yes, because the coordinate points here, the coordinate of X and Y here, I'm sorry, of point P is X and Y. This is for Y, this is Y here, this is X. So that means from here, please let's understand, from here to here is what? Is X. Okay. Now, remember this is the what? This is the origin. At this point, we have A along the x-axis. So from here to here now is X minus A. Try to understand, please. Yes, try to understand. You have seen why I wrote X there. And this is A because this one our focus. It has A at this point and 0 for Y respectively. Because since the point lies on the origin, Y will be 0. So this is a difference between X and A is X minus A. So I want to consider the right angle triangle here that I've formed there. Okay? And at the same time, this point to this point, if I call originally this point is X, Y is equal to 0 here, and at this point Y is equal to Y. I hope you understand. Because Y on this horizontal line, on this origin, will be 0, but here it will be Y. So that will lead us to say that using our normal usual Pythagoras theorem, or yes, we are familiar with, if you want to find PS now, PS will be the square of the opposite plus the square of the hypotenuse. So which invariably means that we have X minus A all squared plus, now the hypotenuse side, Y is 0 here, you see, 0 to Y, that's Y square will be equals to x plus a. Equals to x plus a. Equals to x plus a. Why did I write x plus a? Fine. Remember my PS is the same thing as PM. Are we together? Yes. My PS is the same thing as PM because I'm looking for PS. And so I know from here to here is x plus a now. Of course, now it's very simple now. From here to here is x plus a. Okay. So now I will have that as my value, which I've considered. So that is distance from here to here. If this is a, this is x. It's okay. And now that will be x plus a, which invariably, and you know this is a locus too, because it's half of this. So if I create another line here, point here, it means from here to here and from here to here is equal to the same thing. Okay. Now everything is squared. Okay. So by the time we expand this, let's expand it ourselves. Let's do it. Let's do it together. Let's do it. Now, when you want to expand x minus a squared, don't stress yourself. It's not difficult. Are we following? It's not difficult at all. Multiply, first of all, take x squared. Then you are having minus sign, right? Minus. Now, multiply x and a by 2. That is 2xa or 2ax. Yes, that's the logic. Then minus a squared plus a squared. Instead of you expanding to waste your time, take the square of x squared, then multiply x and a by 2. But because our a has minus sign, you have minus x, 2a, that 2 is a constant. It's not the 2 coming here, a constant. Then plus minus a all square will be plus a squared. Then plus y squared is equals to, do the same thing here, x squared plus 2ax plus a squared. Okay, if you don't see that clearly, let me rewrite it. Let me rewrite that one for you to see. So let me write this. We have x squared minus 2ax or xa plus a squared plus y squared is equal to x squared plus 2ax plus a squared. Anyway, you may not be asked to show all this, but I want to show you for you to know how the answers are gotten. So now I think we are getting that. Are we together? Fine. So let's look at some elementary operations there. X squared minus x squared, we are collecting like terms now, minus 2ax minus 2ax, yes, plus y squared plus a squared minus a squared is equal to 0. So this will cancel this will cancel this. Of course, yes. I hope are we following? I want to hear from MTS 106 students. If you are not following, that means I hope I'm not talking to myself. MTS 106 students, are we following, please? I want to hear from you. 106 students. It's not clear. What could have happened? Okay, don't worry, I will make my handwriting bigger. I'll make it bigger now so you will see clearly. Don't worry about that. So I'll make it bigger. So you now have minus 4ax. You should be able to see like that. Plus y squared is equals to 0. You should be able to see like that. I've written it in a bigger lettering now. So which means y squared now will be equals to 4ax. This is an equation of a parabola. That's an equation of a parabola. I hope you can you now see it now? I guess you should be able to see the lettering. MTS 106. It will be good to hear from you, please. Are you there? Okay, thank you. Thank you. Thank you, 106. So let's look at the examples. Our examples will actually shed more light to what we are talking about. All these are just the way we get our formula, how we derive our formula. I am interested in showing you so that we not just be using formula without you know it. Even though in the examination, since you are writing a computer-based test, you will not need to derive any formula. So let's now go to the work proper. Let's go to the work proper. Find the equation of the parabola. Find the equation of the parabola with focus 5 and 4, and directories x is equals to 3, and directories x is equals to 3. Take note of that statement. What are you asked to do there? You are asked to find the equation of the parabola. The equation of the parabola. Now, if you actually look at the way we derive our formula, you will see that we said x minus a, if you can remember, squared plus y squared, which is y minus, whatever y is. Let's say y minus y1 squared is equals to x plus something. That is what we have there. So it's equals to x plus a all squared. Yes, that's how we got that. That's how we got that. So I could replace this a with my x1 so that to make it easier for us. That is it. That's the formula for that. That's what we're going to start with. So here our x1 is 5, our y1 is 4, and our directories x equals to our a is 3. So our a is 3. So, and we can now have what? We can have sorry, this one should be minus a. It's not plus a. Minus a. Sorry, it's minus. So will now be x minus 5 squared plus y minus 4 squared is equals to x minus our a is 3, which is our directory. Our directory is that squared. So let's expand this and see how we will solve this problem. Let's expand. Like I said, this one will be x squared. Then multiply x by minus 5 and 2. That is then minus 2 times 5. That's 10. Minus 2 times 5x. That's a constant. 2x times 5. Then plus, because 5 squared is 25, plus y squared. Multiply y and 4 and minus 4 by 2. 2y times minus 4. That's minus 8y. It's not difficult. Come on. You see, you are having minus 4. Minus 4 times y is minus 4. Then multiply it by 2. That's minus 8y. Then minus 4 squared is plus 16 is equal to x squared is x squared. Then multiply this x by 2 and multiply it by minus 3. That's minus 6x. That's the logic. Then minus 3 squared, that's plus 9. Instead of you trying to expand and waste your time, that's the logic. That's the way you can expand square easily. You expand square easily through that method. It doesn't cost you anything. Just understand how the expansion is carried out. That's all. Just multiply like that. The very first and the last terms will remain there. We retain their squares. We retain their squares. So how do we now go about this? Just do some kind of algebraic evaluation. So you have s squared. You can collect like terms to make it faster. So let's collect like terms. Minus s squared. Beautiful. Then what do we have again? Minus 10x. Abi? Are we together? Beautiful. Plus 6x. We are collecting like terms. Then what again? Plus 25 plus 16 minus 9 plus y squared minus 8y. And then we have taken everything. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. It means one thing. What are we not picking? I mean, what have we not picked rather? We have picked 25. We have picked we have not picked 8y. Oh, okay, we have picked it. So it remains something then. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. Okay, let's mark them out so that we don't rush, we don't confuse ourselves. We have picked that. We have picked minus 10, 10x. We have picked 6x. We have picked 25. We have picked it. We have picked 16. We have picked 9. We have picked 8 y squared. We have picked 8y. So what is now the problem? We have picked okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. Sorry about that. That's not funny. So equals to 0. So this one will cancel this. So this one will be what? Minus 4x. This is 41 minus this. Minus plus 32 plus y squared minus 8y is equals to 0. Yes. So we can rewrite that now as, let's rewrite this. So by the time we rewrite this, we have what? Y, we put y to come first, y squared to come first. Yes. Then plus minus 4x plus 32 is equals to 0. Yes. Fine. That is good. Now, what next do we do? You will observe that this particular parabola is y variable is squared. It means the parabola is open upward or downward for the value. So since its variable y is squared, it is a parabola with opening facing forward, facing upward or facing downward. So now we need to find a perfect square for this expression. And how do we find a perfect square? We now use what we call complete square method. Please try to get this method very well. You are going to deal with y. We only deal with x because x does not have a square. That's it. So we are going to consider y that has square. So now say using complete square method, by completing the square method, we have, okay, now by complete square method, what do we have? Fine. So we are going to think of the number we are going to add to y square minus 8y. Let me clean this. So later we use our notes to know. If we want to go back to the question, then we get it from the notes. So by complete square method, we have, all right, sorry. So what do we have? Y squared minus 8y plus minus 8 all over 2 squared. Oh, are we together? Minus 4x plus 32 is equals to 0. Are we together here? You are wondering, what did I do? How come? The coefficient of y here is minus 8. You divide it by 2. That's the way we do complete square method. That's the way it has to be done. Okay? So that will be what? That will be y squared minus, let's go ahead. Y squared minus 8y. Are we together? You soon hear me? I hope you are hearing now. Are you hearing now? Can you hear me now, please? Let me know, please. Can you hear the sound now again? Can you hear the sound now again? Hello? Can you hear the sound again? You be able to hear me again, please? You be able to hear me again, please? Okay. Now, what I said is that last time I said you have gotten 2y dy dx equals to 4a. You now find you now make dy dx as the subject formula. So you divide both sides by 2y. So it will be dy dx equals to 4a over 2y. So with that, we get dy dx is equal to 2a all over y, because 2 here 1, 2 here 2. So that 2a over y is your slope along the tangent line. Now is dy dx, because you know dy dx is the same thing as slope. Is gradient. Is the gradient is the same thing as slope? They are the same thing. So we have gotten that. Having gotten that, now let's now write the equation of our target that we have learned in differentiation. Can you still remember where we say y minus y1 equals to dy dx into x minus x1? Can you still remember that? Wow. So at x1 y1, now at x1 y1, the y dx will be, what do we get there? 2a over y1. Our y will change to y1. That's it. So now the equation of the tangent, therefore, the equation of the tangent will be y minus y1, which is equals to what? Dy dx into x minus x1. Yes. So that will be what? Y minus y1 is equals to, our dy dx what? 2a all over y1 into x minus x1. Yes. So that is the equation of the tangent. Now, if you want to find the equation of the normal, just find the negative inverse of your gradients. That's it. Oh yeah, let's do that. Before we look at examples, let's do that. We are going to look at the example to illustrate all these derivatives of formula we are doing. Okay, don't worry, please. Oh yeah, since the gradient of the tangent and normal must be equal to -1, so therefore, since you can write since before it says since x1 y1 as lies on the curve, since it lies on the curve y1 square equals to 4ax. You know, that's the curve, that's the parabolic curve. Hence y1 minus 4ax1 is equal to 2ax minus 2ax1. Oh, you are asking how come all this now? What happened? Okay, you remember I said y minus y1 is equals to 2a over, what's the gradient? 2a over y1. Good. 2a over y1 into x minus x1. This is what we got. What gave us this? So by the time you multiply through by y1, are we together? You have what? y1 minus y1 squared is equals to 2a into x minus x1. So by the time you open up, you will get something like this. Okay? Yes. And remember your y. Okay, now let's open up. So we have what? We have opening up, we have y1, yes, minus y1 squared is equals to 2ax minus 2ax1. And our y1 square is originally 4ax. That's why we have this. But at the curve, on the curve x1, y1, your x1, x will change to x1. It's as simple as that. Okay. So this one is what gives us this one. So it's the same. You can just look at it. So we can write the equation of our normal as this, or we write it like this. It's the same thing as far as the curve equation is concerned. Don't worry. The example will open your eyes. Don't worry. So the required equation now, therefore the required equation is now going to be y1 is equals to 2a into x plus x1. Why? Fine. Now y1, this one is already what? This one is already 4ax, which we have sorted out, into 2a plus. You are subtracting your x. It's going to be x minus x1. So this it should change to plus. So x plus x1. Okay, x plus x1 from that. If you subtract this, don't get it twisted though. Subtract this from here. Let me not confuse you here. Oh yeah, let us do this. I actually want us to go to the example, but let's do this so that you don't think you are being misled. Now open it up. You have y1 minus 4ax1 plus 2ax1 is equals to 2ax. Is that not? So y1 minus 2ax1 is equals to 2ax. Abi? So we have y1 is equals to 2ax plus 2ax1. So you can see now. So you have what? y1 is equals to 2a into x plus x1. That is what we got there. So I hope that should be clear enough for you. So the equation of the normal, this is the equation of the tangent. So the equation of the normal from the curve will be, since the equation of the normal, let me take my time. Let me write it. Since we have gotten the equation of the tangent to be this, so let's find the equation of the normal, please. Let's find the equation of the normal. All right. Now, equation of the tangent is y minus y1 is equals to 2a over, I think 2a over what? Over y1. Yes. Into x minus s1. That's the equation of the tangential equation. Now, with respect to y1 squared is equals to 4ax that we got. So the equation of the of the normal would now be negative inverse of the gradient. That will be y minus y1 is equals to minus y1 over 2a into x minus x1. This is for tangent. This is for normal. To the curve. That is it. So let's look at examples. The examples will guide us. And we open our eyes more to see what we didn't see before. When we are deriving the formula, and actually in the exam, nobody will ask to derive all this formula, to be honest. This is just for tutorial class. So we are going to solve example now. We are not deriving any formula again. Because I know you would not always like going through the rigors of deriving formulas. So let's solve this example. Find the equations of the tangents. After this example, I'll release the question I wanted to give you. So we call it a day. Find the equation of the tangent to the parabola y squared is equals to 48x at the point 3,12. Then 48, minus 48. These are the 2 points. Show that these tangents are at right angles. And find their point of intersection. Yes. For them to be at right angle, the product of their gradient must be equal to -1. So I think we have written the question. Let's solve this. Okay, let's begin to solve it here. Now, Now, if you compare this value, y squared is equal to 48x with the equation of the parabola, y squared equals to 4ax. You see that 4a is equal to 48. Yes. So 4a will be equal to 48. So a will be equal to 48 over 4. So a will be 12. I think that is settled. Fine, we have gotten a, which is our directory. So our a is 24. I mean, it's 12. Now for the tangents at the points. Now let's quickly do this. For the tangent at the point, we are going to use this later. So we use it we take the note of this from the note. For the tangent at the points 3 and 3, 12. Target at point 3 and 12. 3 is what? X1. Y12 is Y1. Okay. So we have Y1 is equal to 2a into x plus x1, which is our final equation that we got there. So that will be y. That is what? Y times 12 is equals to 2a. What did we get for a? 12 into x plus our x1 is 3. So that will be 12y. If you like one, but don't let us go there. Cancel this. You have y is equals to 2 into x plus 3. So that's y equals to 2x plus 6. Yeah, 2x plus 6. So that's the for the tangents at that point. But at 48, at point 48 and minus 48. At those points, x1, y1. Yeah, let's just do the same thing. Y1, that is y times our y1 is what? Minus 48. So y into minus 48, I'm using this formula, equals to 2 times our a is 12. Then our x plus x1. What is our x1? Our x1 is 48. So we have what? Minus. So I think let's expand this. Minus 40. I want us to get this is minus 48y. Y equals to 24 into x plus 48. Yes. So we can divide through to get y. Now y will be divide both sides by minus 48. Minus 24 over 48 into x plus 48. Are you don't be confused, please. Don't be confused, please. I divide through by 48. Since this is already in bracket, 24 over minus 48. So that will be what? Y equals to minus half into x plus 48. So this is the value, this is the equation of that particular target at the point 48 and minus 48. Now, I think that's correct. So which we can, when we expand this, we have y equals to minus half x minus 24. I think this, yes, minus half x minus 24. The first one was y equals to 22x plus y. Now, for them, when they now intersect, for them to intersect, that means the value of their y will be the same. Because the question says that so that these tangents are at right angles and find their point of intersection. That means for them to intersect, that means they are right angles to each other. So with that, I believe you can just equate this to that. So by the time you equate that to that, you will definitely get x equals to, you check that, x equals to minus 12. Try that. I want you to try that. So by the time you now multiply the product of their gradients, you have minus 1. So that shows that they're actually at right angles, because the product of their gradient, when this goes to minus, I want you to do this yourself. That was why I said I will. That's why I gave you x equals to minus half. So equate y you obtain here to y you obtain here. So find the value of x, you get minus half. So I want to quickly give you the questions which I want to give you before we call it a day, because I promise that there will be a giveaway, and that is very, very important. That's very important. So at the end of this class, I will want those that could quickly solve this problem. We'll solve it
The first 5 students that are able to solve it, they should send the solution to my Gmail. So I will now pick those first 5 students and ask them to send me their, phone contacts. From there, I will take it up. Let me quickly write the question for you. Show that the equations of the tangents from the points 4, 6 to the parabola y square equals to 5x are 4y is equals to 5x plus 4 and 4y is equals to x plus 20. So I'll be expecting your response as soon as possible. Thank you. So we have come to the end of the class today. See you next time when we will be having our live session. God bless you all.